Let us look at the advanced questions in this topic. So there are four identical charges, okay, tied with threads on a tetrahedron, okay. And now the thread connecting the particles A and B is cut. So if this is the particles, this thread is cut, okay. What is the maximum speed acquired by every particle in the subsequent motion? So after this thread is cut, what is the maximum speed? Okay. So what will happen, tell me, each of these particles are repelling each other. So the threads are in tension right now. When you cut this thread here, you see what will happen. Okay. See, there is a repulsive force between these two. So this will get pushed this side and they'll go this side, okay. And you see the motion of these two charges. See, as the center of mass initially is at rest and there is no external force. So finally also center of mass has to be at rest, right? So that means when these are going down, obviously if the net center of mass is still at rest, these should go up, okay. So you see the subsequent motion of these charges will be, like a butterfly flapping its wings, okay, going up and down. Now at which point or which orientation will the charges have maximum speed? See, where the potential energy is minimum, these charges will have maximum speed because the maximum potential energy is getting converted to kinetic energy, okay. So here they all are very near initially, like this, okay. They are very near, and when they move farthest, the potential energy becomes minimum. So at that instant, the speeds will be maximum, okay. So let us calculate what are the speeds. See, initially the particles were like this, okay. They had some potential energy. The separation between all the particles are the same except these two particles, okay. So we don't need to take into consideration the potential energy of this and this and this and this. Why? Because the separations are all the same every time. We need to take into consideration the potential energy of only these two for our calculation purpose, okay. So initially the thread is of length L, so this is of length L, okay. So what are the sides? All the sides, if it's a regular tetrahedron, all sides will be of length L, right? So now this triangle will be of side length L. So what will be this distance, tell me, from here to here? If I tilt it like this, it will be something like this. It will be something like this. If this is L, this will be how much? Root 3 L by 2. So this will be 60 degrees, equilateral triangle, sin 60 root 3 L by 2. So total will be root 3 L. So this whole thing will be root 3. Okay. Next, what about the speeds? How will the speeds be? From symmetry, see these two speeds, suppose the speed is u. Obviously from symmetry, the speed also will be in downward direction. We know that the center of mass is at rest. Okay. So momentum of the center of mass is 0. So if these two are going down with speed u, obviously these two have to go with speed u, so that the center of mass momentum is 0. So this also will have speed u in this direction. This also will have speed u in this direction. Okay. So yes, now we can calculate what is the change in potential energy. Tell me. So work done by electric forces equal to negative change in potential energy. Okay, that is equal to what do you call change in kinetic energy. So this will be u initial minus u final equal to ke final minus kinetic energy initial is anyway 0. What is the initial potential energy? We are considering only these two charges, so that will be kq square by L minus finally kq square by root 3L equal to, finally all the four masses have speed u. So the total kinetic energy is 4 times half mq square. Okay, so now we can just simplify. What will we get? Tell me in this. Kq square by L into 1 minus 1 by root 3 equal to 2m u square. So simplifying, we get u as this answer.